They spray our skies,
interacts with the magnetic
chemicals.
field of your body.
Space travel is space. Mars rover is a complete...
Stop!
Hi, I'm Rich Lund, and welcome to another episode of Debunk the Funk. In the last two episodes, we've tested the waters with this chemtrail conspiracy idea, looking at both the easily debunked claim that certain types of snow can burn, and we also examined what would an actual chemical spray look like compared to just a condensation trail made out of water vapor. If you want to catch up to speed, you can check out those two different episodes. Links to them are in the description below. From the comments that I've received on those two videos, I know that I'm ruffling some feathers here. But in this episode, we're not just going to tiptoe around the idea. We are now delving straight into the weakest part of this argument. And here it is. If the world governments are spraying these chemicals everywhere, then we should be able to find these chemicals everywhere. Where are all these chemicals? And on the heels of that question, what are the specific chemicals that we should be looking for? A personal hero of mine, the late great Dr. Carl Sagan, once coined the phrase, "Extraordinary claims require extraordinary evidence." And another way to say the same idea is that the magnitude of the evidence must match or surpass the magnitude of the claim. If a student were to tell me that they didn't have their homework today, but they had done it the night before, they just left it in their book on their kitchen table, well, a note from mom is probably all that's really needed to support that claim. But the cliche, "the dog ate my homework" claim, well, that's a little bit more outlandish, and I might need some more evidence than just a note from mom. I actually did have a student tell me that once, and they brought in the remains of their homework. Definitely looked mangled by a dog. And they had a note from their parents saying that yes, they witnessed it, and witnessed the retrieval of that paper, pulling it out of the canine carnage that was happening. That student had brought me in both, and that was definitely the magnitude of evidence needed to support that claim. I let her redo the assignment, gave her full credit. So if the chemtrail enthusiasts wish to warn us that the world governments across the globe are spraying their populations with chemicals, that is a tremendously large claim. It's going to take more than some photos of some clouds in your backyard in order to convince a skeptic. If they are spraying us with chemicals, then we should be able to find these chemicals that they're spraying us with. So just exactly what are the chemicals that we should be looking for? Already, this is where the chemtrail conspiracy wildly falls apart. 9 out of 10 times, if asked this question, I've found that the chemtrail conspiracy theorist just wants to keep talking about clouds. That's the comfort zone, and they want to stay in it. See, I've engaged multiple times online with chemtrail conspiracy proponents, trying to find out just exactly what chemicals is it that I should be looking for that I could test for in my backyard. And when I do get an answer that 1 out of 10 times, the variety of different answers I've gotten has been staggering. You can often tell when you're traveling into some unknown territory with a certain school of thought when you start to get different answers for the same question. When it comes to just what chemicals are they spraying on us, there does not seem to be much of a consensus. Here is a list of just some of the chemicals that I've been told, be it from people online or from websites they've directed me to, as to what's in these chemical sprays. But I'll also point out, many times I've been directed to certain websites that never really pin down what the chemicals are. See, in pseudoscience, there's an advantage to being vague. If you never actually report what the chemical is, well, then you can't be disproven. If you never tell me what to go look for, well, I can't go look for it and maybe not find it. And this is really the linchpin of the entire argument. If they're spraying us with these chemicals everywhere, then we should be able to pin down exactly what are the chemicals, because that chemical or mixture of chemicals would be found everywhere. Now the best I can do though as I muddle through this is go with the two chemicals that I have heard most often when asked what chemicals are they spraying. The two most common answers I get are aluminum and barium. You can find some websites and some random tweets and blog posts about the dangerous aluminum and barium that people are claiming is fallout from these chemtrails. And just as an aside, if I got the picture wrong somehow and you think you know what the actual chemical or chemicals are, well, go ahead and let me know in the comments below. But make sure that you also provide your source of information. That way I can go check that out too. Now, while it wasn't a huge number of times, there were a few occasions where I was directed to go to the website geoengineeringwatch.org. It looks very authoritative, and in their health section they warn of the dangers of aluminum. The same website also has a section where they explain to you how you can collect samples of rainwater and recommendations as to how to send it out and get it tested. Now, when it comes to sending out rainwater and getting it tested, there's plenty of labs that'll do it. Usually they'll charge you a little bit more depending upon how many different chemicals you want tested for. Farmers and other ecologists have been doing this for years. Geoengineeringwatch.org recommends that you test for at least aluminum and barium. And they also encourage that when you get your results back, that you email or fax them your results. That way they can post them on their website. That way anybody who wants to can download those test results and read them for themselves, along with your personal name, address, and phone number. On many of the tests, geoengineeringwatch.org didn't redact any of that personal information. Nice job. Now, here's some of those tests, and don't worry, I made sure to take out the personal information that the website was a little too lazy to do. Check out some of these aluminum numbers. Whoa. Are these large? Small? Normal? Off the charts? Should we be alarmed? When I say alarmed, I mean scared enough to go buy books and documentaries made by these chemtrail enthusiasts. Well, I scoured the website and I didn't find anywhere where they were stating what they considered to be an unsafe level of aluminum or barium. Admittedly, I didn't check the entire website. It's a big website with lots of pages. But still, I would think that if they had such levels to report, they would have put them right there on the web page where they're talking about testing for aluminum and barium. However, there are other places online, blogs and message boards, where people are sharing their results. And they're discussing these results as being unsafe with reference to an EPA standard of 0.2 milligrams per liter. If that's the limit, 0.2 milligrams per liter, well then this Colorado sample of 0.8 milligrams per liter, that's 4 times the limit, right? Whoa. And here's one from my home state of Michigan. Whoa, 786? Oh, no, wait, never mind. That's in the units of micrograms per liter. So in milligrams per liter, that's just 0.786. But hey, that's almost as bad as that 0.8. That's almost 4 times the safe limit. And here's some test results from Oregon. 19,000, 20,000, 38,000. And yes, those are in the units of milligrams. This is tremendously above the 0.2 limit. Oh, wait a minute. Upon closer examination, despite these tests being reported on the rainwater test page, right next to all the rainwater test results, these are actually soil tests. That's milligrams per kilogram of soil. Perhaps they should watch geoengineering a little bit less and how they report their data a little bit more. But hey, mistakes happen. And still, those numbers from Oregon, they're alarmingly high, aren't they? Well, they only are if you accept the chemtrail enthusiast claim that 0.2 milligrams per liter is the safe limit. But wait, that's from the EPA. That's authoritative, isn't it? Well, yes, that is an EPA limit, but no, it's not the safe limit. Some very important details are being left out. The first thing to understand is that the EPA has set this limit for drinking water, not for rainwater. This is a limit that the EPA recommends that municipal water treatment facilities adhere to. But wait, it gets better. You see, the EPA has both primary and secondary water regulations on different chemicals. Chemicals that can cause safety and health problems are considered primary regulatory chemicals. EPA has safe limits for those, and those are enforced by the federal government. Meanwhile, the secondary regulation chemicals, these are ones that actually don't pose any known health risks. They're chemicals that aren't dangerous, but they are ones where if they have a significant concentration in the drinking water, well, they're going to be off-putting to the public that receives that water. In large enough concentrations, secondary chemicals could cause an odor or a taste in the water that people don't like. In other cases, it's a technical problem where having a high enough concentration of this chemical can cause corrosion or sedimentary deposits in the plumbing. Something very expensive to repair for the people buying this water. And you guessed it, aluminum is a secondary regulatory chemical. They set the limit at 0.2 milligrams per liter because if it's above that concentration, well, the water starts to look cloudy. Starts to have kind of a gray color to it. So just so we're on the same page here, in summary, 0.2 milligrams per liter of aluminum isn't the safety limit for rainwater, which I don't think you're drinking anyway. But instead, it's the concentration that the EPA recommends that municipalities adhere to, so that way your water doesn't look cloudy and gray. And I do mean recommended. Seriously, they're just suggestions. Secondary water regulations from the EPA are not something that is legally enforceable. Now, if a local government passes their own laws about what the restrictions are on their drinking water, that's a different story. So what exactly is the safety limit for aluminum according to the EPA in drinking water? That's just it. There isn't one. The human body is very inefficient at absorbing aluminum and very efficient at filtering it out through the kidneys. And while we're on the subject, and for those who are curious, barium is a primary regulatory chemical. It does have a concentration that can be a safety risk. The EPA has set a limit of 2 milligrams per liter for barium. And these tests were well below the 2 milligrams per liter of barium, which, by the way, for some of these tests, the units are in micrograms per liter, and that would be 2,000 micrograms per liter of barium. ND either means no data or not detectable, meaning whatever amount of barium was in that sample, there either wasn't any or it was too low for the machine to even detect it. But wait, not so fast. What about those soil samples? Those are high numbers still, right? No. First of all, you can ask any geologist, any earth science teacher, any ecologist, anybody who knows a little bit of chemistry, or Google it for yourself. What are the 3 most abundant elements in the Earth's crust? By mass, number 1 is oxygen, number 2 is silicon, and number 3 is aluminum. Coming in at, on average, about 8%. That's right, about 8% of the Earth's crust is aluminum. Not aluminum the metal, but aluminum in a mineral compound. And furthermore, this 8% of aluminum, well, that can actually vary widely depending upon what the actual location is. The U.S. Department of Health and Human Services has a special branch, and that is the Agency for Toxic Substances and Disease Registry. And according to them, soils will have a range of aluminum present anywhere from 7 to 100 grams per kilogram of soil. So even the highest one here, 38,000 milligrams per kilogram of soil, that's just 38 grams per kilogram of soil. Definitely within the normal expected range. Now, soil isn't just earth. There's plenty more to it. There's organic material, plenty of other chemicals and nutrients. I get you. But let's not forget the fact that a lot of it is just ground up earth crust. And 41% by mass of the earth's crust is feldspar. Feldspar contains aluminum. And whether we're talking about rainwater or soil testing, these tests are run the same way. They use plasma flames. Samples to be analyzed are sent through a machine where they are injected into an incredibly hot plasma flame. These flames, though they can be hotter, are usually around 6,700 degrees Celsius. That's 12,000 degrees Fahrenheit. No molecule or chemical structure is able to survive that intense amount of energy. And so the chemicals break down into the individual atoms. The samples get atomized. You want more details, go ahead and Google it. And this is also why when you get such test results, you don't actually get to know what compounds were in your samples, just what elements were present in whatever compounds were in your samples. Elemental aluminum looks the same to these tests as aluminum in a compound does. So these tests are not able to distinguish aluminum that was in some sort of compound contaminating your soil compared to aluminum that was actually making up part of your soil. And the same goes for barium too. While certainly less abundant than feldspars, the mineral barite, barium sulfate, is widespread around the globe. So when we have soil tested, we would definitely expect to see aluminum levels, and we might see some barium in there as well. Okay, but how would aluminum or barium or both get into our rain? Aha! Well, actually, very easily, and we'd expect it to. See, it's all about the dust. Perhaps you've heard the little startling factoid that the majority of dust is actually shed human skin cells. Ugh. But that's only true of the dust around your home and places where humans tend to frequent. You see, there's a difference between what's called domestic dust and environmental dust. The term dust is actually a pretty broad one. It really can apply to any very small solid particle. In the case of environmental dust, the majority of dust that's out there is actually very small rock and sediment particles. Things that are on the scale of millimeters, micrometers, or in some cases even a few hundred nanometers. Any rock or sediment pieces that are small enough for the wind to be able to pick up and blow around fit this definition. And at the high altitudes where precipitation actually occurs, well, dust is there. And in fact, it helps the precipitation occur. It participates in the precipitate. You see, the solid dust pieces give the moisture a place, a solid surface to condense upon. At the center of almost every raindrop is one or more incredibly small solid pieces of dust, which could easily be an aluminum or at times a barium-containing piece of rock or mineral. So again, back to the original question, if they are spraying us with chemicals everywhere, shouldn't we be able to find these chemicals everywhere? Well, I guess the answer is yes, just so long as those chemicals are the ones that we would expect to be finding everywhere already. Before we go, one last thing to think about here. Consider this. If the proponents of chemtrails are telling us that the government is trying to secretly spray us with these dangerous chemicals, then why are the chemtrail enthusiasts using an EPA set limit for safety? They do understand that the EPA is a government agency, right? I mean, just entertain this idea for a second. If the government really were spraying us with these chemicals and didn't want to cause a panic, well, why wouldn't they just tell the EPA to raise the limit? You can kind of start to see that as skeptical as the chemtrail enthusiasts claim to be, they didn't really put a whole lot of thought into this one. Hey, thanks for checking this one out. I'm Rich Lund, and I'm here to remind you, the world needs critical thinkers. Make sure you're one of them. See you next time.